So we have a solid. We're trying to estimate the volume of the solid. Well, no, we're not trying to estimate. We're trying to find the actual volume of the solid. So we're not just taking n slices and adding them all together like the kids' project that you guys saw on the link yesterday. Instead, we're trying to find it exactly, and to find it exactly, what needs to happen to these slices? Thinner and thinner and thinner and thinner and thinner and thinner and thinner, and approaching the impossible two-dimensional slice. Can I do that by hand? I can't add together infinitely many. What can I do? Take a limit as n goes to infinity, and what is defined to be the limit as n goes to infinity of the adding together of all the different volumes? An integral. So what I could do, and where this could come from, I know this is the forever card, I'm not adding to the forever card, I'm adding below. If we were going to take the limit as n goes to infinity of all the different slices being added together, I would use a summation. It would make my life so much easier. Starting at one slice and going to n slices, going to 5 and then 10 and then 100 and then 1,000 fit into this finite space, so they're getting thinner and thinner and thinner. Except I wouldn't just do a height, I would actually do an area times a delta x sub I. Because remember, volume is defined by area of the base times the height, or area of the base times the depth. And so I could do the area of, if it's a pi r squared, if it's a circle, if it's an s squared, if it's a square, a base times height. If it's a rectangle, a pi r squared, I already said that one. 1/2 pi r squared if it's a semicircle, and we'll see some other ones today. But we would do an area formula, area of the base times the height times the depth. And what is this defined to be? Well, for some sort of x interval, for some sort of x between a to b, guys, isn't this the limit of the infinite number of slices as the slices are getting thinner and thinner and thinner? Isn't that an integral? So what does the integral do? It solves the limit for me. It does the impossible for me. All I need to put in is an area formula with a dx. Remember? The integral is defined to be the limit as n goes to infinity of a Riemann sum. But this time I'm not Riemann summing rectangles. I'm not Riemann summing rectangles, I'm Riemann summing slices. I'm not Riemann summing rectangles, I'm Riemann summing slices. And it's not the rectangles that are getting infinitesimally thin, it's the slices that are getting infinitesimally thin. And technically we'd say, in the circles that you guys just saw, the cylinders. Okay, so we saw square slices yesterday, we saw rectangular slices yesterday, and we saw an area between can be the basis, literally the base, literally the foundation to these three-dimensional figures popping up out. But then I also showed you, hey, we could also have done semicircles. We could have also done semicircles. Now, some of you might be able to visualize what would happen, and some of you are like, I don't know what's happening. Because anywhere you would go, slicing, you'd have semicircles coming out. Anywhere you would go, you'd have semicircles coming out. And for all of these semicircles that are being generated by this figure, question, every time, what dimension, what measurement of the semicircle is being defined by the top minus the bottom? What part of that semicircle is that? Well, the area between is what we could think of for the top minus bottom, but what measurement of the semicircle? Yesterday, for the square, wasn't the top minus bottom the s or the side? For the rectangle, wasn't the top minus bottom the base and they gave us the height? What is it for the semicircle? The diameter. Do you see it? We want the radius, but what is that literally? Isn't that the diameter? Like if we were to keep drawing it, or if we were to keep drawing it, or if we were to keep drawing it, and technically you kind of have like this little shape and it'd be formed by, and it would have this weird and it would go down. It would kind of be like a tier, sort of. Not a very good tier because it would be flat on the back. It'd be a really awkward shape, but either way, we don't need to worry about what it would look like. We just need to realize when you pop up in a semicircle, that's a diameter. And a diameter, if that's the top minus bottom and I need the radius, what are we going to do to top minus bottom? Divide it by 2. So then what am I plugging in when I need the r, I need it in terms of x, and so I look at this and say, okay, top minus bottom, didn't we see yesterday that was x plus 1 minus x squared minus 1 for this example? Right? So I would plug in my top minus bottom, I'd divide it by 2, and then I'd rewrite. Now guys, there's no way. If you were just writing the integral expression, let's say this is an awesome problem and they're not making you solve at all by hand or by calculator. They just want the integral expression. They wouldn't write it like this in the multiple choice. So what would this end up looking like? If you were to simplify. Pull out the half, you can pull out the pi, you can also pull out the this. Yeah, and the square root of the top, well, we got that, and it's with variables, so we're kind of stuck with him, and we could probably simplify this a little bit, and we will. But what would happen to the over 2 that's squared? Over 4, and then it would combine with the 1/2 to be a 1/8. And I guess we would simplify, because 1 minus 1 would end up being 0, so then you would have like an x minus x squared. I don't think they would FOIL it out. I think they would leave it just like that. But there would be a 1/8, which is weird because for a semicircle, you would think there should be a 1/2, and there was. But then the radius divided by 2 squared, well, there's a 1/4 that also came out. That would be the integral expression representing the area of, the integral expression representing the volume of the solid formed by semicircular, because we didn't actually have a problem for this, so semicircular cross sections bounded by y equals x plus 1 and y equals x squared minus 1. How did we get -1 to 2 yesterday? Because it wasn't in the problem that was given for the other two. Oops, my bad. It wasn't given in the wording at all. Those bounds were not given. So how did we find -1 to 2? If they're not given, they must be natural. And how do we naturally find intersections? Set them equal to each other and factor, right? So when this one was on the board when we first came in, did you guys start pondering it at all? Do they give us any given bounds? No. But do they tell us how we're supposed to be slicing? Yes. Okay, so hold on. If we're doing squares, and they give us that it's bounded by this function, is that a function? X squared plus y squared is 4? Why is it not a function? You can do a couple different reasons, but the easiest one would probably be that it fails the vertical line test, right? But another way of seeing it is, well, hold on, are we supposed to be doing dx or dy? Yeah, because if you slice it perpendicular, you can do a slice. Pretend like it's a top minus bottom. Oh, it wouldn't be top minus bottom, it'd be a, if we're slicing perpendicular to the y-axis, wouldn't that be a right minus left? But this is not section 6.1. We're not doing area between. We're not just looking at that little slice. We're looking at the three-dimensional slice that's coming up out. And guys, doesn't a square have sides that are the same? So whatever that distance is, I'm going to have a square slice defined by it. Here's my question. Is this a dx or a dy? Is the depth horizontal or vertical? I'm hearing it. AJ, say it louder. You're good. Yeah. The depth is vertical because it goes up, or it goes back. It goes up, down, the depth, right? So if it's vertical, it's not going to be a dx. It's going to be a d. But wait, your forever card. Is there another way of figuring this out? What did it say? Perpendicular to the y-axis. Is that a thing that leads us to where we should go? Yeah. So you might be visualizing. You might be drawing the picture. You might be looking at that and saying, oh, hey, it's a dy. Or you might just be memorizing the wording and being like, okay, good. Whew, it's a dy. But to set up my integral expression, don't I need to go ahead and say, okay, fine, dy, I need an area in terms of y times the depth. Those are my three-dimensional slices with my cross sections. But what are my bounds? Y bounds or x bounds? So if you look at the picture, it's kind of easy, right? How low do you go? How high do you go? 2 down and 2 up. So technically my bounds are going to be, what's 2 down? -2 to 2. Now, that was fairly simple if you remember that x squared plus y squared is 4 and is a circle, and is a circle is a circle with a radius of 2. However, what if you didn't remember that x squared plus y squared is 4 with a circle of a radius of 2? How do you naturally find bounds with something like that? There's not 2 curves, there's only one. Well, let's start talking about area and see if we can figure out another way to find the -2 to 2 without remembering it's a circle. Area. We have squares. What's the geometric area of a square? Side squared. So what's my side defined to be? Oh, but it's only 2 at one place. Everywhere else, wouldn't it be a little bit less than? Actually, it'd be 4. It'd be 4 right here, because it'd be 2 this way, 2 that way. So 4 would be the side there. But doesn't it go all the way from 4 all the way down to 0? Because here there's going to be no distance when it's at the radius of 2 or -2. So it's going to go from 4 to 0. Well, how do I do that? Not top minus bottom, but you're close. Right minus left, like Patricia said. I could say it's going to equal right minus left, but here's the problem, guys. Don't I need to actually get a function in? So do you remember from section 6.1, if I need to be plugging in terms of y, what do I solve for in my equations? Yeah. Go ahead. Think section 6.1. What happens when we solve for x? Your guys' turn. Except how many functions do you get when you subtract? Because it's plus or minus. Well, that's confusing. Oh, no, it's not, because these aren't functions, because it fails the vertical line test and the horizontal line test. Either in terms of x, top, bottom, it fails, or in terms of y, right, left, it fails. So what does that mean? If I was to color code and I was to say the positive one is going to be green and the negative one is going to be black, and both of them together make the circle, what part of the circle is the green positive square root of 4 minus y squared, guys? Yeah, it is the... That would be the 4 minus y squared. So what's the black going to be? The other side. The negative square root of 4 minus y squared. And how can you know that? X's are sometimes positive and sometimes negative. X's are positive to the right of the axis, and x's are negative to the left of the axis. I can state it as one equation, but I can't state it as one function, x equals y equals, because it's plus or minus square root. There are 2 branches because it fails the function test. So what do I do with that information? How do I write my right minus left to get my s to plug into my area formula? Who's on the right? The positive square root of 4 minus y squared. Who's on the left? The negative square root of 4 minus y squared. Wait a minute. They're like terms, and I have 1 minus a negative 1, which is 1 plus 1. Doesn't that end up just being double? Does that make sense? Is there symmetry to where the area on the right will be the area on the left, or the distance on the right will be the distance on the left? So you could have done the positive square root minus the negative square root, or you could have just been like, hey, it's double that. Either way, you end up at the exact same place. Now, what do we do with this s? Square it. Why did Rachel say square? Not to get rid of the square root, but that is going to happen. The area formula. We're not plugging in S, we're plugging in area, and area is S squared. Does that make sense? So then we'll throw in that 2 square root of 4 minus y squared. What if you had to do this by hand? Ugh, so mean. We already did integrals for like 2 whole chapters, chapter 4a and chapter 4b. I know, but you still need to know how to do them. How do we do this by hand, guys? Pull out the constant? Okay, so pull out 2, right? Whoo! Someone just caught your mistake. Or am I trying to get you into a mistake? Why would it be 4 outside? Now what happens to my square root squared? Square root goes away. Okay, quick review, because I'm scared some of you are going to forget. Calculus kids at every level at one point usually make this mistake. How do I solve the integral? Careful. Derivative of 4, I'm not deriving, would be 0, but nope. It's not just 4 because I need to do something. It's 4y because I need to anti-derive, right? What's the antiderivative of y squared? 1/3 y cubed, or y cubed over 3, and I'm plugging in from negative 2 to 2. Remember, every integral for me to solve, I always, always, always have to anti-derive. So now aren't we just plugging and chugging, cool kids? If I can get it to go. So I can plug and chug and get, if you guys want, you can leave the 4 out, because he's going to be multiplied by everybody, and then I end up with 8 minus 8/3. Don't forget those parentheses, and then negative 8 minus negative 8/3, so plus 8/3. Can I just learn a little bit about your brains right now? What would your brain say to do as far as simplifying right now? Perfect. Then what? You're not going to leave anybody hanging out there, right? Rewrite that 4. Now what's your brain say to do? Combine like terms. So 8 and 8 is 16. And negative 8/3 is 16/3. We okay? Distribute. I would advise not to. Just because the 4 and the 3 won't cancel, so you're going to have to somehow combine those if it was a multiple choice matching. So if I were you, instead of having to get 64 to be a common denominator, it'd be easier right now to get, 16 into thirds. Mental mathers, double check. Is it 48/3? 48 minus 16. You guys are at least somewhat mentally thinking of what that is as a subtraction, right? So 32/3. So then AJ, theoretically, now the multiplication is a little bit smaller because I got to subtract when you bring in the 4. And you guys are hopefully into, right? Into column multiplication, right? So you end up with but does the process make sense? So ready? I want you guys to collaborate in your groups and solve the exact same problem with the exact same foundation with different cross sections. His area formula is nasty. Let's do this one next. I'm going to switch the order. Let's do semicircles next because we've already talked about semicircles. We have an example of semicircles in our notes. You guys are allowed to collaborate. It's the exact same foundation, slicing the exact same way perpendicular to the y-axis. Ready, set, get as far as you can. I think yesterday we had the same foundation and we did 3 different types of volumes. Same thing today. guys realize when I draw this, I'm just drawing a representative one. Like I could draw it anywhere, right? Like a little, long, I could draw it anywhere, true? Okay. That's a little intense. Did you guys get that it was diameter? So then if diameter is your 2 square root of 4 minus y squared, I didn't have to do all that work again, right? Okay. If the diameter is that, what's the radius? Divide by 2. Did you think about the area formula being 1/2 pi r squared? Did you think about how volume, still going from the same bounds of -2 to 2, from the lowest y to the highest y? We'll plug in that 1/2 pi r squared. What'd you guys do? Did you plug in the whole shabam and then simplify, or did you cross out the 2's and then plug in? Yeah, I would do that too. So where's the 1/8 this time? It's not there. The 1/8 is what happened last time. When I divided by 2, it got squared, but this time I had symmetry, so what was on the right was on the left. There's this weird double of the square root anyway, so it just crossed out. So then if you simplified this, you should have pulled out the 1/2 and the pi. Integral from -2 to 2. The square root squared cancels out. How do we do? What you know? Well, my area formula. So you could plug in the diameter if you want, but you would need to change the formula because I have to have it equal. So either way, I have to divide by 2. Does that make sense? Good. Good. Ryan.
All right. So if you're always trying to find the equation for the part of the area of the shape that's changing.
Yeah.
Like the length, like in this case, it would be the radius.
Mm-hmm.
Then.
Which, pause, the way Ryan said that was good, because he said I'm getting a formula for, in this case, the radius, because it's always changing. I can't say 2, I can't say 1, because those slices, you guys get they're always changing. Okay, go ahead, Ryan, sorry.
You need right minus left every time for these formulas, right?
If we're slicing perpendicular to the y, because we're slicing right-left. Perpendicular to the x, top minus bottom, and everything would be in terms of x instead.
Yeah, and you just always set it equal to a certain variable depending on if it's top minus bottom or right minus left. So
Exactly.
If it's top minus bottom, it would be you set it equal to y.
Right. You would get y equals instead of x equals.
Okay.
And you would still have a plus or minus square root, because in this shape, whether you're measuring in terms of y or in terms of x, to be honest, you get the exact same half sphere. So in some ways it doesn't make a difference in this case, but it made a huge, or it would make a huge difference in something like this, where the boundaries are different. If you're slicing top-bottom, it's going to be a very different generated volume than if you were slicing right-left, if that makes sense. Once I get that cool program that wasn't working yesterday downloaded on my computer, hopefully Mrs. Christensen can do it for me today, we can see kind of the differences that occur with every kind of foundation besides a circle. But a circle just happens to have the exact same symmetry either direction, so a circular foundation actually makes no difference whichever way you slice it. But every other foundation that has differently defined boundaries, it is going to make a difference. Okay, why did I leave this guy for last? I'm not even going to do the isosceles right triangle. Why did I leave this guy for last? He's not hard as far as being able to draw him. He's not hard as far as being able to slice him. Slicing him right to left still. Equilateral triangle means this is going to be the lengths of my sides, right, guys? So we can say it's going to approximately go there and be about the same lengths either way, right? Isn't my depth still going to, oh my, that was very dramatic. Isn't my depth still going to be dy? But what's hard in this problem? Why is Rachel saying height? It's the area of a triangle, and don't 1/2 base times height? We know the base, right? But what's the problem? This is B, this is B, this is B, but what else do I need? So if we needed that, couldn't I sounded like alphabet for a second. Lo siento. Unless you haven't seen Alphabet, the Wicked Witch of the West. Anyway, unless you haven't seen Wizard of Oz. I did bring it up earlier this year, though, behind the curtain. Anyway, we want to find H. We don't know H, but we do know B. And they didn't give us an H clue, but wait a minute. If that's B and that's B and that's B, is H somehow related to B's? What do you think? You don't want it to be, but it is. With an equilateral triangle, guess what? This little guy splits him in half. It's a bisector. I know, geometry. We should all sue. Just kidding, don't sue. If we zoom in on that triangle, isn't there a relationship between, I don't know, like opposites and hypotenuses and adjacents? Couldn't I say Pythagorean theorem, if I'm trying to find H, couldn't I say something to the effect of H squared plus 1/2 B squared is equal to B squared? A squared plus B squared is C squared. Do you see how I can solve for H in terms of B? Oh, there actually is a formula you can memorize, but I'm trying to show you how it does work. H squared is equal to B squared minus B squared over 4, which would be 4 over 4 minus 1 over 4 would be 3B squared over 4. So then H equals, the square root of 3 times B all over 2. Because I can square root him and I can square root him, I just can't square root him. Seriously? Yeah, seriously. So when I go down here to this formula, I can actually make this all in terms of B. And I can end up with root 3 over 4B squared. Guess what? There is a geometry formula out there that has that the area of the equilateral triangle is root 3 over 4s squared. Well, that's fun. But why does that make all the difference for us? Did they need to tell us H? No, it's unlike the rectangle. And we talked yesterday about the rectangle. If they don't tell us the rectangle's height, well, we don't know. It could be anything. But in this, if it's an equilateral triangle, no. This H is going to be defined every time to have this relationship. So the easy thing is we could memorize this area formula. I've never seen equilateral triangles or isosceles right triangles show up on an AP question where they don't give you the formula, which is nice. But you could always find it yourself or you can Google, is there an area formula too? But now that we have it like this, it's like, oh, no big deal. Can't we just say from -2 to 2, root 3 over 4? Wait a minute, what have I not done yet? Yeah, but why haven't I? Guys, isn't B just the right minus the left, and the right minus left we've done a few times now? Does that make sense? The right minus the left was the side of the square. The right minus the left was the diameter. Oh, stink. Right, Janelle? Divide by 2 to get the radius. Okay, we got it. And then the right minus the left is the B. Oh, sweet. Just plug it in. Are we okay? Okay. So if they change up the shape on us, the cross-sectional slice shape, does it really change a lot? No, but can you guys help me out as far as summarizing? When the shape changes, but the foundation doesn't, that the shape is being generated up out of. I'm trying to think of a good analogy for that. It sounds like some sort of marble something or others, or something and then something comes up out. But anyway, forget it. If the volume is generated up out of the foundation, what has changed, or what have you had to think about changing between the square to the semicircle to the equilateral triangle? Good. We have to somehow think about the area. And if possible, it's weird, try to get it in terms of just one variable. So think about the area formula. What else did we have to think about? Specifically with semicircles. The radius. We had to actually think about what is our missing guy and how does he relate with the right minus the left. Does that make sense? So this tells us dy, this tells us right minus left, but every time we have to think about who is this guy and how does it relate. The b was right minus left, easy. The s for squares was right minus left, easy. The semicircles, the right minus left was the diameter, so we had to say, oh, okay, all right, we need radius divided by 2. Is that cool? Okay. So let's go tackle an AP question or two. Hey, you're allowed to have your calculator. Grab it out. Look at those decimal answers. So do you have to kill your brain thinking about what these graphs look like? Well, wait, they're basic. Yeah, I know. You could be fine. But do you have to kill your brain if you're allowed to use your calculator? Okay, so what might be a good idea? The base of a solid is the region enclosed by. Would it be really nice to know what the foundation looks like? Ready, set, go. You graph, and I'll play with the basic graphs in my head. But if you want, you can do y1 equals, y2 equals. Uh-oh, that's not a y, is it? Well, maybe just graph y equals ln of x and then be like, how do I do the other guy? I don't want to just give it away right away. I want to let you think about it at least for another second or two. What would this picture look like? If you don't have a calculator, it's okay. They're basic graphs. Don't worry, e is just the natural number. Nick named it really well yesterday. Oh, that was after school. But e is just the natural number. Natural number has a value, right? What's e approximately? Yeah, good, good, good. 2.71828, 1828, 1828, 1828. It's like a tick mark on the x-axis, right? An awkward tick mark, but a tick mark nonetheless. Can I show you the foundation yet? Are you looking at your graph with an ln? Have you made your x max be e? Did you think about that? You can't do an x equals. There is no x equals in our little zoom unless we go to like parametric mode, which is awkward. But you can cut your window to stop there. Why am I saying stopping there? Because doesn't ln swoop, there he is, at 1. ln of 1 is 0, right? So where's e if it's a tick mark? Here-ish, right? Because if that's 1, well then this could be 2. And that's somewhere between 2 and 3. So did you guys think about this being your foundation? Now careful, it didn't just say ln, it didn't just say x equals e. What did it say as your third boundary to close it in? The x-axis. Do you see what region it was talking about? Isn't this my foundation? Right there? Does that make sense? So the ln is a boundary, x equals e is a boundary, and the x-axis is a boundary. This is a really important skill to be developing, and it started in section 6.1 with area between. When they're giving you boundaries, when they're giving you what's closing it in, you have to think about, because you could shade all sorts of weirdness unless you actually say it has to have ln on one side, x equals e on the other, and the x-axis on the third. That's where my, wait, what's coming up out of that? Squares. Wait, being sliced which way? Because it's not like a circle where all the different directions it's the same. Ah, which means top, bottom, or right, left. So I'm coming straight down. Does that make sense? So remember, this is just representative. It changes as I move, longer, shorter, etc. But that's okay. I'll take this. This defines my square for this one. This defines my square. So what's my thickness, dx or dy? Either according to the forever or according to the picture. Dx because it's a horizontal depth, right? Do you guys see it? Okay. So we're good, right? Because don't we know that we're going, maybe we'll figure that in a second. And we need, maybe we'll figure that out in a second. Okay. We need to figure out some stuff. What's something we need to figure out? Area. Okay, cool. That's the first one I heard, but area is s squared. I heard Patricia say side. Okay, so think about the side. The side is defined to be what? Oh, isn't it just top minus bottom? Okay, who's on top? ln of x. Who's on bottom? Exactly. Do you see it? Y equals ln of x, and then isn't this just, it's the x-axis, which is y equals 0. So I do have two y's, they just didn't show that to me. Oh, so it's just, yeah. So who squared? ln of x squared. Sweet. But what else am I missing? Ugh. Wait. They're x bounds. So what's the x value that started this whole thing off? Careful. Y was 0, but x was 1. And where did I end? 2.718 to, yeah, 1 to e. Guys, throw it in your calculator. Don't you dare try to solve it by hand. You can't. Even the BCers would struggle on this one. Integrating ln, We have answers of ln, but we don't integrate ln unless there's a u sub, and this one's not going to help us out. But throw it in your calculator. It's a calculator question, and let's see if we get a nice little decimal answer that matches. Someone tell me the letter as soon as you get it. Don't forget to square your ln of x. The whole ln of x squared. Michael got 0.718. Do you do a common mistake, or do you guys agree? Michael, it's just because I don't know the answer off the top of my head. Confirm, confirm, confirm. Whoo, that wasn't too bad, was it?
Yeah, let's go, Tom.
Could this have been one that you could have gotten on the AP exam? 1 out of 54? Hey, you got to start somewhere. So what about this guy? And I gave you the picture this time. Oh, I thought we had one more minute. We're so close. That's all right. Guys, we're doing AP practice. What's due tomorrow? Nothing. But wait. Wait. Didn't we just finish 6.2a? Yeah. Maybe, should we start peeking at homework and seeing if there are any cross-sectional ones? Yeah. What on earth else is going to happen in section 6.2b? What if you start with an area and you make the third dimension by rotating? Don't worry, it's just pi squared slices. Bye, guys. Maybe keep watching your online tutor and go look at discs and washers. Maybe keep watching your online tutor and go look at discs and washers.